محدثنا الثاني هو السيد توني كاش، كبير مهندسين الإطفاء في هيئة النقل بلندن، رئيس جمعية حرائق السكك الحديدية بالمملكة المتحدة. السيد توني كاش متخصص ولديه خبرة طويلة في قطاع السلامة في حرائق النقل. يمتلك أيضا خبرة عمل واسعة على مدار ما يقارب 30 عاما في العديد من المجالات، ومنها النقل الترفيهي والعمومي والطيران ومجال النفط والبتروكيماويات والملاحة البحرية والسلطات المحلية. يمتلك أيضا خبرة كبيرة في تطوير المتطلبات ذات العلاقة بشهادة وفحوص المنتجات، وكذلك السلامة من الحريق، إضافة إلى خبرته الطويلة بمجالات هندسة السلامة من الحريق في القطاعين العام والخاص. فالآن فليتفضل السيد توني كاش ليحدثنا حول حوادث النقل الجماعي. Please, Mr. Tony.
Assalamu alaikum. Good morning. On behalf of the Mayor of London, I would first of all like to thank His Royal Highness, Your Excellencies, your Ministers, and the Major General for your very kind invitation to speak at this collection of civic emergency planners and excellencies. I'm very pleased to be amongst you and to come back to the United Arab Emirates. It was around 1994 when I first came to the Emirates, and I'm very pleased to see how your developments in fire safety technology have expanded throughout the decades. It's certainly very much humbling to stand amongst such excellent presenters on whom we in Transport for London depend to a great deal when catastrophe strikes. I've not been a firefighter, and I always marvel at the ingenuity of some of the things that are done to bring calm into what otherwise would be quite a catastrophic surroundings. Let me begin first by showing you a little of our history. We were very pleased last year to celebrate our 150th birthday. And I heard discussions about preparation. Now, let's just see how this works, because one of the things the Mayor asked us to do in the face of all of our excellence in modern technology was to do something for the city and to return to the city the age of steam and elegance. In 1863, the City of London became quite crowded. It depended upon the rivers for all of its transportation. And listening to the presentation from the Chief of the Fire Service in Hamburg brought recollections to mind of the wide range of things that I could speak to you about today. We have, of course, the Port of London Authority. We have oil refineries out on the edge of the Thames. We have the flooding of the recent weeks, and we have the Thames Barrier. We have all these things to protect us from the adverse weather conditions. In 1840, the railways began in the United Kingdom. In 1863, the Victorians had the remarkable insight, as the river became more congested with private boats and ferries, to take transport underground. So London Underground has been keeping London moving since 1863. We didn't have quite the elegance of Herr Klaus's emergency services when we took the fire service underground. We had very simple arrangements, because when we talk about fire safety technology, one of our main precepts is to prevent fires from beginning in the first place. Mr. Dean spoke about the built environment and the advances that you've had here in the Emirates in your design and your complexity. Our major challenge is to transform public transport in London whilst keeping London moving. So we carried some of our resources with us on the train, and we have never had to use them. So we carried water, pumps and extinguishers, and we carried emergency evacuation ladders with us. But this is the technology of the Victorian age brought to bear into the modern time. So the key thing here is the gas lighting. In 1863, when we had premium first-class accommodation in the noxious odours of the London Underground, the carriages were built of prime quality materials, mahogany, teak, wood panelling. This material here at the back is papier-mâché. And here in the middle, we have a gas mantle. So the trains were lit by flammable gas. One of the main things that we do in fire safety technology in London Underground is to eliminate all flammable and combustible material. So the challenge to modern technologies was that, for example, this had to be replaced with a modern equivalent that would not cause problems. So our engineers came up with light-emitting diodes. So to all of the people that came on the train to sit in the first-class Victorian luxury, it looked like a gas lamp, but in fact it was a light-emitting diode. And that small innovation was the single most important development that allowed us to bring steam trains back into London in the 21st century. I remember the phone call from the Mayor's office 2 years before the birthday of the London Underground. Fire safety engineers will not stand in the way of the celebration of our birthday. So now we have a dynamic tension. We have the tension between what our lords and masters wish us to do, and we have the expectation of the whole of the eyes of the world upon the London Underground. All this 1 year after we hosted the first transport safety games in the world. Some of you will remember it as the London Olympics. It was claimed by many people that we would not be able to run the Olympics on public transport alone. So here we are with the oldest railway carriages in the world, in the most modern railway underground system in the world, the only one to be in public ownership. Here we see the steam engine being coupled up at night to our electric locomotive, which we still maintain. So in terms of emergency preparedness, we had a number of issues to overcome with the London Fire and Emergency Planning Authority. I'm sure in your refineries you have some very, very well prescribed methods for hot working. We have in the United Kingdom a collection of regulations wrapped up in the Regulatory Reform Fire Safety Order and the Subsurface Railway Stations England 2009 regulations. In essence, these prohibit any hot working on the railways without any significant mitigation. The first thing I had to do was to persuade the London Fire and Emergency Planning Authority that we were not undertaking hot works. Now, we were going to carry a fire-breathing dragon through the tunnels of the London Underground, bellowing out steam, smoke, and the interaction of that steam and smoke with our modern methods of detection and intervention was something that I had to consider in the emergency preparedness. It would be very simple to just turn off all the fire detection and alarm systems. And that was possible in the night time when we were rehearsing. So we had some very successful trips with lords and ladies in their finery on the steam train at night. And I sat at the end of the platform with the Commissioner for London as we eagerly waited for the first train to arrive. There's a reason why I show you this picture. This is Moorgate. Moorgate, some of you will remember, was the scene 29 years ago of a catastrophic overrun by a London Underground and British Rail train. It resulted in many people being killed, and many of the staff who work on London Underground have within their psychology now the mantra of coming to work safely to go home safely, and nobody wishes to contribute to the loss of life. Here is the steam train at Moorgate. We have a particular requirement that at any time on the railway you should always be able to see 10 metres ahead of you for clear escape paths. As Herr Klaus mentioned, it's very important to have safe access and safe egress for the emergency responders. You can imagine the scene when the steam train came in. All of a sudden, you could not see your hand in front of your face. All of a sudden, we found out from our exercises that every single smoke detector within the station was signalling fire because of the steam. So we came up with a not ingenious plan, but a very sensible one. We do not maintain a fire and rescue service in London Underground. We depend upon the London Fire Brigade for that. We do maintain an emergency rescue unit. We maintain fire safety engineers like myself, and we have about 29 or 30 of them. And the plan we came up with was simply to give the accountability and the responsibility for safety to the fire engineers. The problem with that is that in the United Kingdom, if you wish to run a railway, you have to have the permission of the Office of Rail Regulation. So we had to come up with a plan to enable each station's fire alarms to be turned off just before the train came in, with manual fire watches put in place, and then to be reinstated as soon as practicable when the train had passed. Here we are with two of our trains side by side within a few minutes of arrival at Moorgate Station. Here you can see how we reenacted the era of the Victorian age. We had quite an issue with crowd control. This gentleman here wasn't to protect the band in case they played badly. This gentleman here was to protect the infrastructure, the railway, from the attention of the press, the media, and what we kindly refer to in the United Kingdom as train spotters. On each train we had 200 or 300 guests, paying guests, but we also ran the railway with modern trains alongside, and we ran steam trains within the normal working timetable. This brought to bear a number of pressures to our reputation. The one important thing about Transport for London is that we value time. That is our only objective. We know that people wish to get from one place to another in the shortest possible time. One thing I will tell you about the time when this took place is you will remember shipping incidents on the magnificent and catastrophic scale. Do you remember the Titanic? And do you remember the famous auction at the same time that we were doing this of the violin from the band who played on whilst the Titanic sunk? One key decision we made was that we would not allow a violin player to sit in this four-piece band. We substituted with an additional trombone. Our mayor loves to broadcast his successes throughout the world. We actually had the mayor blowing his own trumpet one day. Now, that's just an insight to what we can do when we put our minds to things. We've seen how ships can cause a great difficulty to reputation. I just want to show you a little bit of this film. This is a news report of a Zeebrugge incident.
Disasters.
This rescue ship that we're aboard spent the whole of last night searching for the living. Today, the search is for the dead. The authorities have long since given up any hope that anyone has now survived within this wreck.
a white wall of water came crashing into the ship.
I had to work out when to take the biggest breath I could possibly get, because if I'm going underwater, that breath has got to last me until I can do something about it or die.
On a freezing March evening in 1987, a Channel car ferry capsized 2 miles off the Belgian coast. 193 people drowned. This was Britain's worst maritime disaster since the sinking of the Titanic.
We had about 40 or 50 bodies just laid out on the floor, just covered in sheets, blankets, whatever was available. And you realise the scale of the thing.
It was one of the hardest things I ever had to do, was to tell a father and one child that the mother and the other child were not on the list.
The reason I show you that clip of film is because there are many lessons that can be learned, and the principal lesson that Klaus mentioned was also played out here in the 1980s, long before anybody had disaster preparedness in the front of their minds. This was a holiday trip. The Herald of Free Enterprise was owned by a company called Townsend Torreson, a company which is no longer in existence. Holiday tickets were sold through the newspapers. The offer was such that if you bought a particular daily newspaper, you could travel overseas for £1, and you could take your family with you. It was a wonderful experience for people who could normally not afford to travel. And of course, nobody imagined that their holiday would end up in that kind of situation. And what was the most probable cause? The most probable cause was a lack of coordination and communication between the ship's captain and the loading bays. The ship set sail without the certainty that the bow doors were properly closed. In the roll-on, roll-off ferries, the scenario is that the ship comes into port and the vehicles are loaded on at the rear. It then turns and it moves across on its journey. The bow wave overcame the protection of the doors. The mass of the water very quickly disturbed the centre of gravity of the ship, and in a very, very short period of time, the ship was forlorn. The consequence was that the reputational risk to the company was immediately harmed. Now, you will remember the aviation incident on Manchester Airport for British Air Tours. This was a completely preventable accident on the runway. Preparation of not having sufficient of the runway fire hydrants available for use by the fire service handicapped the intervention by the professionals. The pilot, in positioning the aircraft in such a position that the fire could immediately enter the interior and engulf the aircraft in a very short period of time, was a significant contributory factor, as were the furnishing and fittings of the interior of the aircraft. This is the reason why in London Underground we control the materials of construction so very strictly. It is often said that we control the material and the fabric from which the railway is built with such an obsession, the like of which is seen only on submarines and in space missions. So predominantly we ensure that the fire will not begin in the first place. We then move to very, very early intervention and an immediate call to the fire and rescue services, whilst also mobilising our emergency response unit. We employ our staff to very good effect with initial investigation. And of course we learn from other railway undertakings, which brings me to the presentation that I want to just show you of a lesson learned that we do on the railway. Every week or so, our safety professionals come together to give a talk about an incident that has occurred somewhere else on the railway. This is the United Kingdom, where in 2007 an intercity express train derailed in the north of the country. This train wasn't travelling particularly quickly, and in the same way that the incident occurred on the Herald of Free Enterprise, and in the same way that many incidents have occurred in road transport, aviation transport, maritime transport, here on the railway we will see a common factor. The presentation uses material from the Rail Accident Investigation Branch final report, and this shows you something regarding where the incident occurred. It was quite remote. This is the the northwest of the United Kingdom, a very calm and relaxing part of our country, near the Lake District, near Kendal, and it was just on the railway where the condition of the points and the sequence of the failures led to catastrophe. The investigation immediately caused London Underground and Network Rail to consider its operating procedures. You would wonder where there is a similarity. Here we are in the capital city running trains to carry more passengers in a single day than the whole of our national railway network carries in 1 week. Our safety record is far better than the National Railway. We're 11 times safer according to the regulator, and we are 200 times better than the worst metro railway in the world. Our reputation is significant and worthy of protection, so we learn from others. We use similar points in switching the path of the railway. This shows you generally how the points are comprised. Oh, let's go back. The idea is, as the train moves, there is a stretcher bar which holds the switches and the blades apart. And when the signalman changes the direction of movement of the train, these bars move, and this blade and this blade have to move together, and they're separated by what is referred to here as the stretcher bar. The sequence of failures was such that there was a systemic problem in the way that the stretcher bars operated to keep the switchblades apart. This is the third permanent way stretcher bar at the incident. You can see here what's happened. There was a fracture of the stretcher bar, which means that the point switch would not move simultaneously to change direction of the train. That was the second, and that was the first. Here's where they're locked, and here's where the detector rod identifies their position. That was the bolt, and like so many catastrophic failures, it's the combination of factors where one simple problem gives rise, together with poor fortune, to the catastrophic event. In terms of the investigation, a number of factors were very quickly eliminated. This had nothing to do with the way the driver was acting. There have been many notable high-speed rail incidents in the last few years where suspicion has been placed immediately on the behaviour of the train's captain, driver, pilot man, whatever you would like to call that individual. This train was relatively new in its design at the time. We have them in the United Kingdom. They're called the Pendolino. If you visited and travelled on Virgin Railways, you will have sat on a Pendolino train. They are designed so that when you go round the curve, they lean, hence the name, the Pendolino. They're very similar in their design to the intercity express trains that are used for high-speed routes in mainland Europe, for for example, in Germany and in Spain. And one of the things that are outruled is weather, adverse weather. We've heard so much, and we heard about the UK government advisor talk about adverse weather. We've had railway lines washed away by the embankment slipping. And at Greyrig, one of the concerns that people had was because of the mountainous terrain, perhaps the ground was unstable. But that wasn't true. The investigation focused on the actions of the signal controller in the signal box. The signals are controlled from quite some considerable distance from the scene. And of course, the mimicking of the signal pattern is shown to the controller. The signalman wasn't fatigued. The signalman didn't switch the points incorrectly. The track geometry. There was a concern that perhaps the track was old and the train was new. Somebody was concerned that perhaps the rail had become deteriorated so that the interface between the fast-moving wheels and the rail was such that the train would be upset and would be tipped off the rail, so that if the train slipped sideways, there was sudden a jolt or a jarring which would cause the following carriages to turn and derail. And we mentioned the condition of the earthworks. Here were the causes and the factors. The causes and the factors were discovered by the subtle investigation of the singular bolts that were captured at the scene. So here's one of our very significant lessons learned: preservation of evidence. Always a railway manager must be dispatched to the scene to preserve the evidence. No work should take place in the immediate aftermath of an incident. There's no surveillance out in the remote countryside. It's not like the middle of London, where we have more CCTV per square foot than any other capital that we are aware of. If there's an incident on the London Underground, I can immediately recall high-definition closed-circuit television footage of the time leading up to the incident to the time after the incident for up to 30 days thereafter. But the remarkable thing is that I can have instant video playback at any one of my stations. The importance of that is that if a contractor who is employed to do work on our railway has done something that leads to the intervention of the emergency services, when I'm deployed, or in fact, as it has happened since just before Christmas, when my role was expanded to include compliance for fire safety, when I choose to deploy myself, and when I choose to walk onto the railway, my badge with my logo gives me the authority, as a level 1 responder, to interact straightforwardly with the senior police or emergency services personnel on the scene. I'm very proud to say that for all the time I've worked in civil aviation regulation and on the railway, I have never had to use my authority to intervene at an incident. Here's the second lesson learned: respect. It's of the ultimate importance to have a mutual respect for every single one of the operatives involved, whether it is in prevention, whether it is in protection, whether it's intervention, or whether it is salvage. The most important thing for London Underground is to respectfully return the service to normal. We have quite a number of people fall under trains. We have to respectfully deal with those incidents, think about their relatives, but keep London moving. The lesson that we put into the mind of everybody that works for the railway is to respect the environment in which you work. We saw photographs of the first and second stretcher bars. The third one was still complete and was connected to the switch rails. What happens as a train passes over points is that if the points switch, of course the rear of the train suddenly wants to take a different route to the front of the train, and that caused the derailment. Why did the point switch? It was discovered that it was a human performance limitation. Lots of people walk the railway at night and when there are times of low train activity to visually inspect rail and points. The supervisor carrying out the scheduled basic visual inspection on the track on the date before did not include the points, the subject of which caused the derailment. The construction of the points was a standard design, well proven and well tested, which hadn't given any difficulties for nearly 35 years. The missed inspection was caused not by that particular individual, but because of the very limited access time for maintenance on the West Coast Main Line. You obviously don't like to mix personnel and trains. As the gentleman who taught me how to work on the permanent way, the railway, described to me on my first induction for safe working on the track, he said, go to any accident emergency department within the United Kingdom on a Saturday night between 11 p.m. and midnight. You will see lots of casualties from car accidents, lots of casualties from fires. How many railway trains will you see waiting for triage? There will only be one loser when you mix people with trains without effective control. So we have a very strict method of access. On London Underground, we only have 3 hours in the day to do all our maintenance. The city does not sleep anymore, but we used the time when everyone else was asleep to go and do track inspections and to tighten the bolts and check the movement. The reason why the supervisor did not conduct the safety inspection was because of the pressure of gaining access to that part of the track. Therefore, the accident was dormant, waiting to occur, and the incorrect setup of the points, the excessive residual switch opening, caused the difficulty whereby this blade would therefore not move in unison with the other blade. And it was inevitable that sometime in the future the train would suffer. This just shows you the patrol route. It shows you that this is a 5-mile scale here, and this is where the track workers would walk and physically inspect. The maintenance team would have to deal with the area from Carnforth to Oxenholme to Boroughbridge and to Penrith. There's where the incident occurred. There's the patrol lengths, and it simply was that in the time allotted for their inspection, they did not have sufficient individuals deployed to do the work necessary. The management arrangements were poor. I said to you that we deployed our fire engineers when we were running the train underground. That takes an incredible amount of scheduling. We are limited to working 8 hours in a shift, during which time we must have had 8 hours clear rest. That's 16 hours for a 24-hour day. It should immediately become obvious that you can't just have 2 people working day and night, you need a third person to give relief. So I had 24 fire engineers working for each of the 2 days, leapfrogging each other between the stations and going by foot or by car to get there before another one would relieve the other of his or her duties. It could not have been done without us having implemented some of the things that the Fennell inquiry into the King's Cross disaster discovered. Airwave radio. So that shows us some of the concerns that human factors would bring up. We use something now called a Hardlock nut. You may come across it as a nylock fitting. It just stops the nuts from breaking loose. That's all it does. It costs 30 or 40 pence. But it ensures that with paint markings on the nuts, you can immediately see if the points are in a serviceable condition. So we use high visibility paint markings on all the points so the patrols can see the condition of the situation. We went through lots and lots of fault analysis to identify how things could be done better, and we ensured that with remote point control monitoring, you didn't have to send people out all the time. We invested in a rail inspection train vehicle where the inspectors sit on the train and cameras are mounted to bring to them visual records of what the track condition is like. There were 29 safety recommendations in the Rail Accident Investigation Branch report. At the Manchester incident, in aviation, there were 55 recommendations by the Air Accident Investigation Branch. The risk to the reputation of any organisation is to arrange for all of those recommendations to be completed satisfactorily so that there is no remaining doubt that the railway, the maritime, the aviation, or any other industry in which you work of is, to every extent, as reasonably practicably safe for all of those who use it. That concludes what I want to say, because the greatest thing at risk is your reputation, and the greatest tool in your armoury to protect it is technology with good psychology and good behaviours. Thank you so much for the opportunity to share something of what I've learned from fire safety professionals such as yourselves with yourselves at this conference.
Thanks again, Tony Cash, giving us an insight there on the kind of the rail transport aspect. I mean, you started off with quite a light-hearted look at London's preparedness for the Olympics, but I think that the key to take away, and it was interesting there that ultimately what London has done for over a long time is integrated very new technology into a very antiquated system, but then pulling back the antiquated technology into a new system. And it was all about preparedness, but it was really a focus on how to make sure that the risks that they'd identified were sufficiently mitigated in order to allow that to happen. Obviously, they were under a lot of pressure to make that happen, but how could they possibly do it? Then we moved on to the ferry disaster. And I think that particular aspect brings, a really sobering thought, but also really outlines the need for coordination and process, because it was somebody doing something that they knew not to do, which actually caused that terrible disaster, which I recall as well. Again, the same thing, the airport disaster, preventability, it was preventable. It was a process. If the response had, not the response from the emergency services, but if the accident had been dealt with in a slightly different way, it would have had a very different outcome. And then finally, looking into detail, and I know you had to cut that a little bit short, Mr. Cash, sorry about that, but obviously, there's lots and lots of detail goes into those, but it's about learning from our accidents. Accidents will happen, but if we miss the opportunity to investigate thoroughly, analyze thoroughly, and then don't learn from those accidents, then we fail, I think, really. And clearly, what Tony was outlining there was that all of the progress that this and other organizations have made throughout the years is based on learning from accidents and learning from the past and improving constantly. And I think that's an endless process.